Hello there, and welcome to Origins of Earth, where curiosity gets cozy and science drifts gently between wonder and rest. Tonight, our quiet journey takes us far beyond the edge of our blue planet, past the hum of satellites and the glow of cities. And more than that, what if we are being watched? Not in the way cameras watch or sensors record, but in the way a careful observer might study a fragile world through glass. The idea is known as the zoo hypothesis, and it begins with a whisper of humility. If there are advanced civilizations out there, maybe they already know about us.
But for reasons of their own, they've chosen not to interfere. Maybe they're just watching quietly as we build, fight, love, and learn.
Maybe we are the latest addition to a cosmic nature preserve.
The lights dim, the air still, a screen glowing softly nearby.
Or is the sun just beginning to rise, catching on the edges of a window as you start your day? Wherever you are, you and I are sharing the same small moment in the same wide universe. And that alone feels worth noticing.
Now, take a breath, loosen your thoughts, and settle in.
Because before we start to explore the logic, the science, and the quiet possibility behind the zoo hypothesis,
And how it might feel if someone somewhere was seeing us too.
the notion that other beings might exist beyond Earth is not new. Ancient civilizations gazed at the stars.
The Egyptians saw the heavens as a place of order and judgment.
The Greeks imagined deities observing mortals from Mount Olympus or higher still, scattered among constellations. The zoo hypothesis simply places that gaze not in myth but in astrophysics. Instead of gods, it suggests civilizations. Instead of Olympus, a cluster of stars. Instead of moral judgment, quiet observation.
The question that leads us here starts with what scientists call the Fermi Paradox.
In 1950, physicist Enrico Fermi, during a casual lunch conversation, posed a question that has haunted astronomy ever since. If the galaxy contains billions of stars, many older than the Sun, and if even a small fraction of them host planets,
and if even a smaller fraction of those planets are habitable, then there should be countless intelligent civilizations.
So, where is everybody? Why is the sky so silent?
Fermi's question exposed a strange contradiction. Statistically, we should not be alone, yet observationally, we seem to be. The zoo hypothesis proposed in the 1970s by astronomer John Ball offered a gentle, almost polite answer.
Maybe they are there, he suggested. Maybe they see us.
But like careful zookeepers, they maintain their distance, choosing not to disturb the natural development of a younger species.
It's a concept that blends astrophysics with a kind of interstellar ethics. It implies restraint, patience.
In this idea, the universe is not empty. It's simply quiet by choice. Biologists observe animal behavior from hidden blinds so as not to alter what they see.
Anthropologists once approached isolated tribes with caution, aware that contact could disrupt fragile cultures.
The first question most people ask is, why? Why wouldn't an advanced civilization want to make?
Maybe not. Consider the scale of difference. We're only a few centuries into the age of electricity, a few decades into spaceflight, and
A handful of years into interstellar communication attempts. If they exist, they could be millions of years ahead. To them, our languages might sound like birdsong. Our conflicts might appear like weather.
Our achievements might resemble the early stirrings of something promising, but not yet stable.
Perhaps contact is not avoided out of malice, but mercy.
This leads to another quiet thought. If the zoo hypothesis were true, what would it mean for us?
Look up there! It's beautiful!
What is that thing?
Our wars, our kindness, our art, our noise, all part of a data stream watched from afar.
We begin to evaluate ourselves differently. That's a human reflex. Performance, after all, is how we define identity.
It's why we write diaries, even if no one reads them. Observation gives shape to behavior.
And the possibility of cosmic observation stretches that shape to its furthest limit.
The zoo hypothesis might sound speculative, but it connects to several hard scientific principles. One is the idea of the prime directive, borrowed from science fiction, but grounded in real ethical debate. If contact could cause cultural collapse, then advanced species might adopt a policy of non-intervention. Another is the concept of detection thresholds. We might not be technologically capable of perceiving alien signals, even if they're all around us. Just as early humans couldn't detect radio waves, we may simply lack the right instruments or the right understanding to notice what's there.
The universe might already be speaking. We just don't understand the language.
Also a sociological element. Imagine if every civilization that reaches a certain level of technology realizes the danger of broadcasting its presence. The universe is vast, but not necessarily friendly. Some might choose to remain silent, and others might enforce that silence. In such a galaxy, new species like ours would be allowed to develop in peace until they demonstrate maturity.
This interpretation of the zoo hypothesis paints a picture of an organized, cooperative cosmic community, self-regulating and discrete, and
A quiet galactic neighborhood with polite but distant neighbors.
When we send messages into space like the Arecibo signal or the Voyager Golden Record, we're doing more than trying to communicate.
Yet even as we send them, we do so from a place of profound uncertainty. We don't know who might be listening.
It was a feeling of profound peace, a gentle reminder that even in solitude,
That somewhere out there are minds capable of empathy, patience, and restraint. It also places us in a narrative where our story matters enough to be watched.
We build, we destroy, we heal, we wage war, yet the world remains. They'd see a world both beautiful and reckless, creative and self-destructive.
Perhaps that's exactly why they stay quiet. Perhaps they're waiting for us to find balance. To show that we can handle the knowledge of not being alone without falling apart.
That's a generous assumption, but one that fits the gentleness of the hypothesis.
The night sky looks silent, but it's filled with motion. Stars pulse, galaxies collide.
Light travels for billions of years before brushing against a telescope lens.
Somewhere in that vastness could be civilization so old that our entire species has existed only for a blink of their time.
The Milky Way alone holds over 100 billion stars, and beyond it are hundreds of billions of galaxies.
Perhaps it's not absence we're hearing, but restraint.
When radio astronomers listen for alien signals, they listen for patterns, something that breaks the randomness of natural noise.
Pulses once fooled us that way. They're regular flashes, leaving early scientists to nickname them LGM for little green men.
But nature is full of rhythm. The real challenge is distinguishing deliberate communication from cosmic coincidence.
The zoo hypothesis suggests that we won't find such signals, not because they aren't there, but because they've been deliberately withheld.
Maybe they don't see people, cities, or nations. Maybe they see patterns of energy use, changes in atmosphere, electromagnetic footprints. To them, humanity might appear as a glowing patch of activity on a small blue sphere. That's humbling, but also poetic in its own way. Even if we are just one display in a vast cosmic exhibition.
It means we belong to something greater.
The zoo hypothesis doesn't demand belief, it invites thought. It asks us to imagine ourselves not as the
From the void, life emerged, protected by the very fabric of the...
And as we drift through the vast dark, sending out our signals and scanning the silence, the question remains: if someone is watching, what are they waiting for? A moment of peace, a sign of readiness.
Or perhaps they already decided long ago that the best way to help a young species grow is to give it the illusion of solitude.
6. The night continues, quiet and wide, full of unanswered questions, and the story doesn't end here. It stretches onward towards the first glimmers of explanation, where science meets imagination, and the mystery deepens rather than resolves. Because out there, somewhere beyond the stars, might be minds older than time as we know it.
Waiting patiently behind the glass.
It isn't fear exactly, more like the quiet awareness that every pinpoint of light might be another sun, another world, maybe even another observer staring back. The universe has a way of looking still from our perspective.
Lassie. But in reality, it's a restless sea of energy and time. Every star, every particle is moving,
And somewhere within that motion, perhaps hidden by distance or design, lies the answer to one of the strangest questions we've ever asked.
If the universe is full of life, why does it feel like we're the only ones here?
The zoo hypothesis suggests that the silence might be deliberate, that someone or something has drawn a curtain between us and the rest of the cosmos.
It's not a physical barrier, not a wall or a shield, but a kind of restraint, a choice to remain unseen.
To understand that possibility, we have to look at how the idea took shape.
And how it fits into the broader puzzle of our search for company among the stars.
It's an idea that doesn't begin in science fiction, but in the quiet halls of scientific thought.
Among people who looked at the same stars we do, and asked the same patient questions.
In the middle of the 20th century, astronomy was changing fast.
We had built radio telescopes large enough to listen beyond our own solar system.
The possibility of life elsewhere was no longer just philosophy. It was a measurable hypothesis.
When the first signals were sent from the Arecibo Observatory toward the cluster of stars known as M13,
it was a gesture of optimism, a human postcard to the galaxy.
Around the same time, scientists began to wonder why, despite all the possibilities, nothing ever seemed to answer.
That tension gave rise to what became known as the Fermi Paradox, a contradiction between probability and observation.
The logic behind the paradox is simple but profound. There are hundreds of billions of stars in our galaxy.
Many are older than the Sun. A fair number of those stars have planets. Some of those planets are in the habitable zone, where conditions could allow for liquid water and life as we understand it. Even if a small fraction of those worlds produced intelligent life, and even if an even smaller fraction developed technology,
there should still be countless civilizations in the Milky Way. Given enough time, at least one should have reached us. They could have explored the galaxy millions of years ago, and yet, the skies remain silent. No clear messages, no visitors, no signs of cosmic traffic. The universe appears indifferent to our presence.
John Ball, a radio astronomer at MIT, proposed the zoo hypothesis in 1973 as one possible answer.
He suggested that extraterrestrial civilizations might be aware of Earth, but intentionally avoid contact.
In order not to disturb our natural evolution, much like zoologists observing animals in a reserve.
The metaphor was simple and elegant, and it resonated because it offered a solution that didn't depend on extinction.
It suggested intelligence tempered by ethics, a galaxy that practices non-inference.
Unsettling because it turned the silence into something active, intentional.
Instead of a universe devoid of company, we might be surrounded by civilizations choosing not to respond. Imagine a civilization 1,000,000 years older than ours. In that time, it could have mastered interstellar travel, perhaps even developed technologies that operate beyond the limits of physics as we know them.
To them, we might look primitive, unpredictable, even fragile.
Decades of change, marked by both division and remarkable cooperation. The future depends on which path we choose.
Are you reading this, Michael?
Signal clear, Doctor. It's repeating.
There's also a moral dimension to the idea. Non-inference could be an ethical choice. History gives us enough examples on our own planet. When technologically advanced societies encountered isolated ones, the results were rarely peaceful or balanced. Diseases spread, cultures collapsed, entire ways of life vanished. If extraterrestrial intelligence exists and has observed such consequences before, they might prefer patience to intervention. To them, our world could be an early-stage experiment, one that needs to unfold without interruption. The truth, if it exists, might be colder, more observational, less emotional.
The zoo might not be about kindness, but curiosity. Not guardianship, but data.
From their perspective, we could simply be part of a long catalog of emerging intelligences, one of millions of evolving species being monitored.
The experiment is to watch what happens when consciousness evolves on its own terms.
When we consider the scale of the universe, the odds of being the only intelligent life seem small.
Within this hall, every reflection reveals a universe teeming with life.
The zoo hypothesis offers one of the few explanations that preserves both abundance and silence. It doesn't deny that others exist. It just assumes they've made a collective decision to remain quiet.
Perhaps following a kind of galactic code of conduct.
If that's true, it's not the absence of life that defines our isolation, but the presence of self-restraint on a cosmic scale.
For instance, if an alien society observed Earth from light years away, it would see our planet as it was years.
A star 100 light-years away would show them an Earth from the early 20th century. A star 1,000 light-years away would reveal ancient history long before electricity, long before radio waves.
Observation across such distances is like looking through time. If they are watching, they're watching our past. It's possible they've already noticed our signals. The first radio transmissions, television broadcasts, radar pulses. Those waves have been expanding outward from Earth for just over a century, forming a growing bubble of electromagnetic. In cosmic terms, that's small. It hasn't even reached most of our neighboring stars. But within that sphere, any civilization with sensitive instruments could detect the faint signature of intelligence. Structured patterns in the noise, regular frequencies, bursts of communication.
To a patient observer, it would be enough to mark us as aware.
Pride because it means we've become visible on a universal stage. Unease because we don't control who sees us or how we're interpreted. We don't know if our broadcasts are viewed as the first words of a promising species or the noisy chatter of something not yet ready for contact. The zoo hypothesis holds that they're listening but choosing silence, either waiting for us to mature or
retard. To them, time might not be measured in centuries but in millennia. Waiting 1,000 years to grow might seem.
There's also the possibility that we're not the only exhibit. Maybe other worlds are being watched too.
Each at its own stage of development, each unaware of the others. If civilizations arise frequently enough,
there could be countless zoos across the galaxy, isolated by design. Contact might be permitted only.
This space represents the sum of our knowledge on the matter. For now, the hypothesis...
We can't prove or disprove it, because any evidence of alien restraint would by definition be hidden.
but others see its value in the questions it raises, rather than the answers it gives. It forces us to think about our own behavior as a species under observation.
It makes us consider what kind of civilization we appear to be from a distance. Noisy, fragmented, inventive, emotional.
It makes us think about what kind of species we want to become.
If interstellar travel is possible, even at slow speeds, a single civilization could theoretically, in a few million years, a blink in cosmic time. That means if anyone had started long ago, they could be everywhere by now.
The absence of evidence, then, implies not absence of capability, but choice.
The curtain between us and them could be an agreed boundary, a veil drawn for reasons we can't yet understand. Maybe there's a principle that young civilizations must reach a certain level of stability before contact. Maybe we're still too volatile. Philosophically, the idea touches on an old human pattern, the belief that we are being watched, guided, or judged. Whether through gods, spirits, or ancestors, every culture has carried some version of that feeling. The zoo hypothesis translates it into a scientific framework, removing the mysticism, but keeping the awareness of an unseen audience. It's a modern echo of an ancient intuition. That may be why it feels both rational and familiar at the same time.
The Watchers become the new pantheon, distant, silent, but ever present in imagination.
Are there networks of civilizations communicating with each other, exchanging information across vast distances, while we remain in the dark?
Could our solar system already host silent probes? Small, autonomous machines designed to observe without interference? Some scientists have speculated about lurkers, hypothetical devices hidden in stable orbital points or on the far side of the moon, waiting patiently, gathering data. It's speculative, but not impossible.
We already send probes to other worlds. They could have done the same long before we learned to listen.
And yet, even if such watches exist, they would have to weigh the question we now face ourselves. Every year, our telescopes grow sharper, our sensors more sensitive.
We've begun to detect exoplanets, measure their atmospheres, even estimate their surface conditions.
We too are becoming quiet watchers.
Perhaps every civilization eventually reaches this point, balancing curiosity with caution, understanding that observation is not always benign.
A A galaxy where observation is mutual but invisible, where everyone listens but no one speaks first.
In such a system, silence becomes communication. The absence of interference signals respect, or perhaps fear.
Either way, it maintains balance. The cosmos remains vast, populated, and perfectly quiet. What makes the zoo hypothesis so compelling isn't that it claims to know the truth, but that it frames our ignorance in a way that feels meaningful.
It offers a mirror in which to see ourselves, a civilization just beginning to understand how small and precious awareness can be.
Maybe the curtain isn't just between us and them. Maybe it's within us, the barrier between what we know and what we're ready to know. The moment we cross it, the universe might open a little more. Until then, the silence remains both mystery and mercy, a patient pause in the long conversation between minds. And as the sky stretches endlessly above, scattered with light from ages long gone, we keep listening, not just for a voice in the dark, but for the possibility that we're already part of something larger. For as long as people have looked up at the stars, we've imagined that something might be looking back.
That impulse has driven both wonder and science, from the earliest myths to the first telescopes.
Yet no matter how far we've looked, no matter how carefully we've listened, the universe has answered with the same steady quiet.
Not one unambiguous signal, not one confirmed visitor. Just the hum of natural processes.
The more capable we become at listening, the deeper that silence seems to grow.
It isn't an ordinary kind of quiet, the kind that follows a conversation. It's the kind that feels infinite.
A stillness stretching across billions of light years. That's what scientists began to call the Great Silence.
At first, the silence didn't seem strange. The cosmos is enormous, and our instruments were small.
Radio beacons, laser flashes, hints of artificial structure. But the sky remained mute.
The search for extraterrestrial intelligence, which began in earnest in the 1960s, yielded nothing but background noise.
Each new generation of telescopes extended our reach and deepened the mystery.
Statistically, the galaxy should be teeming with civilizations. Observationally, it's empty.
Contradiction is so sharp that it became a problem in itself. Not just an absence of evidence, but evidence of an absence.
The question of why the universe is so silent has spawned dozens of possible answers. Some are hopeful, others grim. Maybe intelligent life is rare. Maybe it tends to destroy itself before spreading.
Maybe the distances are simply too great. Or maybe, as the zoo hypothesis suggests,
we're surrounded by watchers who have chosen discretion over communication.
We expect talkative neighbors because we are talkative. We assume exploration because we ourselves are restless.
But intelligence might take many forms, not all of them interested in conversation.
The first scientific attempts to detect extraterrestrial life were grounded in optimism.
The early SETI experiments, the search for extraterrestrial intelligence, listened to narrow bands of frequencies that seemed universal.
Like the hydrogen line, a wavelength likely to be used by any civilization familiar with chemistry. For decades, observatories scanned the sky, collecting data, passing signals, searching for patterns. There were moments of excitement, brief spikes in data that hinted at something intentional, but they always turned out to be natural sources.
Pulsars, quasars, satellites, static. In the end, the data always fell back into the great even hush.
Maybe advanced civilizations don't use radio at all. Maybe their communications operate through technologies we can't detect.
Quantum entanglement, gravitational waves, or something entirely outside our physics. Our silence in that view is simply ignorance. There's another possibility that makes scientists uneasy. Maybe the silence is intentional, not on our part, but theirs.
In 2010, a paper by physicist Stephen Webb compiled more than 50 explanations for the Fermi Paradox.
Among them was the idea that civilizations that survive long enough to master interstellar communication also learn to hide.
From that perspective, silence becomes self-defense.
A universe where everyone listens but no one speaks would look exactly like the one we see. If the zoo hypothesis holds any truth, this form of silence could be an organized choice, a kind of galactic etiquette, a mutual agreement among civilizations to observe without interfering. Such restraint would make sense in a crowded cosmos.
Interference could cause cultural collapse or even physical danger.
What in the spirit's name is happening?
They are everywhere. Cover the children.
The polite thing to do then might be to wait, to watch from afar until the younger civilization signals that it's ready. That idea paints a picture not of emptiness, but of structure, an unspoken order underlying the chaos of stars.
After decades of sending signals into space, some scientists have argued that we should stop.
Messaging extraterrestrial intelligence, they say, could expose us to unknown risks. Others disagree,
arguing that any civilization capable of harming us would already know we exist.
Hello, Cosmos.
Our desire to be heard colliding with our instinct to hide. We want to be noticed, but only by something friendly.
For those who work in SETI, the silence is both frustrating and fascinating.
We stand on the precipice of infinity, yet our perception remains confined, like gazing through a keyhole at the cosmos.
But intelligence elsewhere might have evolved under conditions so different that our categories don't apply.
Maybe communication itself is not universal. Maybe the very idea of exchanging information is a human bias.
To a species that perceives reality through senses we can't imagine, our entire civilization might be invisible.
Not by distance, but by difference.
The data collected by radio telescopes are vast and complex, filled with noise that must be filtered and analyzed.
Patterns that seem random might hide intentional structure, but without context, we wouldn't know what to look for.
Our algorithms are trained on what we understand, not what we've never seen. There's also a temporal dimension to consider. Civilizations rise and fall.
The lifespan of a technological species might be short compared to the age of the galaxy.
One sends messages into space for 1,000 years, then disappears. Another emerges 1,000,000 years later and hears nothing.
In that sense, the Great Silence could simply be the echo of civilizations passing each other like ships in an endless night.
The galaxy might be filled with the ruins of voices that no longer exist, signals that have faded beyond detection.
Archives buried in dust and distance. From our vantage point, the silence feels absolute.
But the universe has never been truly quiet. Even in the vacuum of space, there is background radiation.
The faint afterglow of the Big Bang, a whisper from the universe's first moments.
That cosmic microwave background is the oldest signal we can detect, and it speaks of a universe that has always been full of noise. Out of the swirling chaos, the brain seeks order, forming intricate patterns to find meaning in the void.
Hello? Is there anybody out there? I'm all alone.
Across the span of human history, from the first philosophers to the modern scientist, we have always looked up and asked, why? Are we the type to reach out or the type to wait? Do we deserve to be found, or should we prove ourselves first?
Perhaps the silence is not a punishment or an accident, but a lesson in patience.
The budgets for SETI programs have fluctuated over the decades, rising with enthusiasm and falling with disappointment.
But the search continues because the question is too profound to abandon. Each new technology brings a new kind of listening.
Optical telescopes now scan for laser pulses, while infrared observatories search for waste heat, signatures of advanced energy use. Others study exoplanet atmospheres, looking for chemical imbalances that could indicate life.
The methods change, but the hope remains steady. Even the silence itself provides data.
It tells us what isn't there, and that too is information.
The Great Silence has become part of our collective mythology, a modern echo of ancient wonder. In the past, people looked to the heavens for signs from gods. Now, we look for signals from civilizations. The universe hum with energy, radiation, and motion, but none of it speaks in a language we understand.
And yet, there's a possibility that silence itself is a kind of message.
It could be the safest way for civilizations to coexist. A mutual agreement not to intrude.
The absence of sound can be as deliberate as a song. On a cosmic scale, it might even be the most stable form of peace.
There's an emotional side to this that science rarely names out loud. Loneliness.
For all our progress, we remain a solitary species on a small planet, orbiting an ordinary star. The great silence presses against that loneliness, amplifies it, forces us to confront the limits of our reach. Some thinkers have argued that the silence is necessary, that it's the condition under which curiosity thrives.
If the universe were noisy with contact, discovery would lose its edge of mystery.
The zoo hypothesis fits into this perspective neatly. The Watchers, if they exist, might understand that growth requires solitude.
Imagine for a moment that one day the silence breaks. A single, unmistakable signal arrives.
Breaking news. We are interrupting this broadcast to confirm that the signal is real. Authorities worldwide are urging calm.
Every radio station, every screed would relay it. Humanity would be united, at least briefly, by the confirmation that we are not alone. It would be the greatest discovery in history.
And yet, it would also end something intangible. The era of wonder would close.
The latest reports confirm a massive data breach.
I'm telling you, the system is completely compromised.
We don't know who to trust, everything is falling apart. The unknown would become known, and the mystery that once kept us looking would dissolve.
Until then, we keep listening. Our instruments hum quietly in deserts, on mountaintops, and in orbit.
Tuned to frequencies that might never answer. The data pours in endless streams of numbers and noise.
Somewhere among them could be a message we haven't yet learned to hear.
Or maybe the message is already around us, embedded in the patterns of existence itself. We discover that waiting is not passive. It's an active form of curiosity, a discipline of attention. Each unanswered call deepens the question. And somewhere beyond the curtain, beyond the reach of our signals, perhaps someone or something is listening to, honoring the same unspoken agreement.
Waiting for us to understand that silence is not emptiness, but possibility.
For most of human history, the act of looking up at the night sky was the closest thing we had to listening. The stars were silent, distant, untouchable. Yet people still felt that there was meaning in their arrangement. Navigation, mythology, calendars, all of them were ways of translating that silence into something the human mind could understand. When modern science began to replace myth with measurement, the impulse to listen never went away. It just changed shape. Instead of asking the heavens for guidance, we started asking for company.
And somewhere along the way, we built machines that could turn that ancient wondering into a literal question sent across the dark.
From the depths of history,
The first deliberate attempt to send a message into space came in 1974 from a telescope in Puerto Rico.
The Arecibo Observatory, one of the largest radio dishes on Earth, transmitted a tightly focused signal toward a globular star cluster called M13.
About 25,000 light-years away. The message contained a series of binary codes that described basic facts about humanity.
It was more symbolic than practical. The stars of M13 will have moved by the time the signal arrives.
For the first time, a species on a small planet had used science to announce, "We exist."
That gesture was an echo of something older. Before radio, before electricity, people sent messages to the unknown through
pyramids, stone circles, cave paintings, all of them attempts to say in one form or another, "We are here." Ipomej was a modern version of that impulse. It represented the same longing, dressed.
In a way, every act of exploration we've undertaken, from launching satellites to planting flags, but as we began sending messages, we also started to think more carefully about what those messages should say.
If the universe is indeed listening, what kind of impression do we want to make?
The first human-made object to carry a message intended for extraterrestrial recipients was the Pioneer plaque,
attached to the Pioneer 10 and 11 spacecraft in the early 1970s. Later, the Voyager missions carried the Golden Record, a more elaborate time capsule, containing sounds, images, and greetings from Earth in 55 languages.
And the river flows onward to the sea.
The record was meant to be a portrait of humanity, a snapshot of who we were at that moment in history.
Those objects are now billions of kilometers from home, drifting through interstellar space. Long after Earth's civilizations change or vanish, those small messengers will still be traveling. That instinct to communicate goes beyond curiosity. It's rooted in survival.
On Earth, every social species depends on communication to coordinate, cooperate, and adapt. It's how we create shared meaning. When we extend that behavior to the stars,
The universe, of course, does not answer in words. Its language is energy, matter, and motion.
But we've learned to translate some of that language into meaning. Every telescope, every detector.
When we capture a radio wave from a distant galaxy, we're listening to an event that happened millions of years ago. When we measure cosmic background radiation, we're hearing the faint echo of the universe's own beginning.
The more we build ways to listen, the more we realize that the universe has never truly been silent.
It's just that the messages aren't addressed to us. They're written in the grammar of physics. Search for extraterrestrial intelligence operates within that understanding. The scientists involved know that the odds of receiving a clear,
deliberate transmission are small, but they also know that listening is a form of participation.
It may seem quiet now, and the seats may be empty, but I have faith that the stories we tell here will find their audience.
Large radio arrays like those in California's Allen Telescope Array or the Meerkat dishes in South Africa scan the sky for narrowband signals.
Frequencies too precise to be natural. These efforts are methodical, data-heavy, and deeply patient. Each bit of information collected is compared, filtered, and categorized. Most of it turns out to be noise from satellites,
radar, or cosmic sources. But within that noise lies the chance, however small, of something artificial.
The signal is stable.
My God, it's actually working.
It never has, but the anticipation keeps the effort alive.
Over the years, some moments have come close. In 1977, astronomer Jerry Amon detected a signal so unusual that he circled it
on the printout and wrote, "Wow," in the margin. It lasted 72 seconds and
came from the direction of the constellation Sagittarius and matched what an artificial transmission might look like.
Some think it was a natural event. Others believe it was genuine, but unrepeatable.
The signal became a symbol of both hope and frustration, a reminder that the line between silence and communication
as a single column of data. Each generation refines the tools and the methods.
It's resolving the data streams now. The pattern is emerging exactly as predicted.
New projects like Breakthrough Listen, funded by private donors, have expanded the search to billions of stars. Even so, the silence continues. The more we listen, the more likely it seems that the universe might prefer to keep its conversations private. Listening changes how we think. It demands patience and humility, qualities that don't come easy to a species accustomed to noise. In daily life, silence often feels like an absence to be filled. But in the context of the cosmos, it reminds us that not everything meaningful announces itself loudly.
The faint hum of hydrogen in a distant nebula, the regular pulse of a neutron star, the background hiss of radiation.
All of these are messages of a kind. They tell us that the universe is active,
Is anyone there? We have been trying to reach you for years through the silence. Please, if you can hear this, respond.
But the universe might operate through subtler forms of awareness.
Some scientists have speculated that the search for life shouldn't be limited to technology-based signals at all.
Instead, we could look for biosignatures, chemical imbalances in planetary atmospheres that suggest biology. Others propose looking for technosignatures, indirect signs of industrial activity, such as artificial heat patterns or large-scale energy use.
If advanced civilizations exist, they might leave fingerprints in the data, even if they never speak.
In that sense, every telescope aimed at a distant star is both a camera and an ear.
It doesn't just see light, it listens for intention.
The idea that the universe might already be full of such signals hidden in plain sight is both thrilling and daunting.
The challenge is that recognition depends on context. We can only identify something as artificial if we understand what's natural.
For example, pulsars, rapidly rotating neutron stars that emit regular radio pulses, were once considered candidates.
When they were first discovered in 1967, the signals were so regular that researchers jokingly labeled them LGM1 for little green men.
It turned out they were entirely natural, but that moment revealed something important. The line between nature.
If we ever do receive a signal that's undeniably artificial, the implications will go far beyond science. It would change our sense of identity as a species. For thousands of years, we've told stories about being unique, central, exceptional. A confirmed message from another intelligence would erase that illusion overnight. It wouldn't just expand our map of the universe.
After centuries shrouded in mystery, the fog lifted to reveal not an empty ocean, but a world teeming with life.
Governments, religions, and cultures would all react in their own ways. But before any of that could happen,
there would be the first realization. A single point of data on a screen, a pattern of numbers that says unmistakably, someone else is out there.
Even imagining it is enough to change how we see ourselves. Until that day, the act of listening keeps us connected to something larger than our species. Every time a signal travels through space, it interacts with dust, gravity, and magnetic fields. By the time it reaches us,
It's resolving. My God, look at the detail.
a burst of radio energy might tell us about a collapsing star. A faint infrared flicker might reveal the birth of a new one.
To listen is to learn not just about potential neighbors, but about the universe's own processes.
There's a humility in knowing that the universe doesn't owe us a response. The signals we send might wander forever, fading into the background noise. But that doesn't make the effort meaningless.
The point of listening isn't just to find someone. It's to understand what kind of listeners we are becoming.
Faith that someone someday might care enough to hear. When you think about it, our planet has been broadcasting for only a tiny fraction of cosmic time. For billions of years, Earth was silent.
Only recently did it begin to glow with artificial light and hum with electromagnetic chatter.
To an outside observer, that change would be unmistakable. Our radio waves have already reached dozens of nearby stars.
Good evening, this is the news. And now, a performance by...
From the ancient world to the future.
We carry the rhythm of yesterday into the promise of tomorrow, a portrait of enduring spirit.
You seriously won't believe it. Wait, look over here.
But the raw, messy reality of humanity. There's an irony in that too. While we imagine sending messages to the stars, we're already transmitting more than we realize.
Every radar pulse, every satellite link, every network signal spills into space.
The universe might not just be listening. It might already have all the data it needs to know what we are.
If we are part of a galactic zoo, the Keepers don't need us to introduce ourselves.
They've been recording the noise of our species since the first radio spark.
They've seen the pattern of our expansion, the rise of our machines, the flicker of our lights on the night side of a small planet.
To them, we're not mysterious. We're just loud.
Still, we keep listening, partly out of hope and partly out of habit.
The great silence
gives way to contemplation. From this stillness, new
In a sense, the universe has always been listening to, though not in the way we imagine.
Every particle, every atom responds to the presence of others. Gravity binds stars. Electromagnetism shapes matter.
Quantum fields ripple with information. Interaction is woven into the structure of existence.
Each new discovery adds another layer of understanding. Maybe someday, the silence will end.
Or maybe it will continue reminding us that patience is part of wisdom. Lies the essence of what it means to be human. And somewhere, perhaps not so far away in cosmic terms, from the outside, we might look less like a collection of nations and individuals, and more like a single restless organism.
If someone somewhere really is watching us, then the question becomes what they would see.
It's one thing to imagine the universe listening, quite another to think of it observing. Observation implies perspective.
Have you no honor left, Sirrah?
Honor perished the moment you set foot in this house.
From the outside, we might look less like a collection of nations and individuals, and more like a single restless organism.
Covering a blue planet.
To an external observer with advanced technology, Earth would be a striking sight. Its atmosphere glows with oxygen and ozone.
Rare signatures of biological activity.
From a distance, those chemical markers would already hint at life.
The alternating light and dark patterns as the planet rotates would reveal oceans, continents, and weather systems. Infrared sensors would pick up the warmth of cities. Radio receivers would detect a planet suddenly bursting with electromagnetic activity.
After billions of years of quiet, to anyone paying attention, Earth would have become interesting in a very short span of cosmic time.
For most of its history, it was a silent rock covered in water and vegetation. Then, in less than a blink, it began to shimmer with signals. That sudden transition might be exactly what would draw attention. Civilizations capable of interstellar observation could catalog planets by their energy use, their chemistry, or their light output.
In that catalog, Earth would stand out. The rise of technology on a planetary scale is visible even from light years away.
The atmosphere contains carbon dioxide and methane from industrial activity. The night side sparkles with artificial illumination.
Satellites trace delicate arcs of reflection through orbit. To us, these are just the byproducts of daily life.
But from an external vantage point, they form a clear signature. Intelligence has emerged here, whose spectrum shows industrial gases, whose magnetic field hums with artificial noise.
The first step in any form of cosmic observation would be to identify such anomalies. Then comes the harder part, interpretation. The first step in any form of cosmic observation would be to identify such anomalies. Then comes the harder part, interpretation.
What exactly are we looking at? Are these signs of a stable civilization, or one teetering between advancement and self-destruction?
From far away, it might not be easy to tell. The data would show movement, energy consumption, sudden changes in temperature and composition, but the motives behind them would be invisible. The watchers would have to infer, to guess, to construct meaning from patterns.
They don't see the planet directly. They see a small dip in brightness as it passes in front of its star.
The watchers, if they exist, would face the same limitation. They would see the traces of our activity, but not the full story. They might know we have electricity, but not how we use it. They might detect our broadcasts, but not understand their meaning.
They might study the shape of our progress without ever hearing the words we speak. From their vantage point, time would work differently too. Light takes years to travel between stars.
Even a civilization only 100 light years away would be watching our early 20th century.
They'd see the first radio transmissions, the first airplanes, the first experiments in nuclear power.
To them, humanity would still be in its adolescence, curious, noisy, reckless, if they were following the zoo hypothesis.
They might have decided that now is not the right moment for contact.
We seek beauty, yet create destruction. We offer aid, but neglect the planet.
They'd see a civilization that can send probes to the edges of the solar system, but struggles to feed all of its own members.
They'd see a planet reshaped by its inhabitants, its forests receding, its climate shifting, its oceans warming.
To an external observer, this might look like a critical phase, a test of whether intelligence can coexist with its own power.
Perhaps they've seen this pattern before on other worlds. Perhaps they know how it usually ends.
If they have archives, and if they've been watching for long enough, they might compare us to others. Maybe there were countless worlds where technology bloomed briefly before fading. Maybe others found balance and thrived for millennia.
To them, humanity would be a case study in progress. Our signals, our energy signatures, our chemical fingerprints, data points in a much larger experiment. That thought might sound unsettling, but it also carries a certain reassurance. It suggests that we are part of something continuous, that the universe doesn't just contain life, but observes it as a natural process. The metaphor of the glass, the idea that we're being watched from behind an invisible barrier, captures something profound.
From our perspective, it feels opaque. From theirs, it might be perfectly clear. They see us clearly.
But we only see our own reflection. In the last few decades, we've started to develop technologies that make us.
Look at the neural structure on this one. It's remarkable.
It suggests a highly complex ecosystem.
We've discovered thousands of them already, many with conditions that could allow life.
With a single step across the meridian, he ceased to merely witness history. He became a part of it. If someone were studying Earth, they would likely have mapped our entire electromagnetic history.
They'd see the first spark of radio, the explosion of television, the sudden clutter of satellite transmissions.
They'd watch our patterns of energy consumption climb rapidly, then start to fluctuate as we experiment with renewables and struggle with scarcity.
They'd notice our weather changing, our ice caps retreating, our coastlines shifting.
They might classify us as a transitional species, one that has just begun to alter its planet intentionally.
Classification alone would be enough to justify continued observation. After all, transitions are where the most interesting data lie. Or would we step in to help? On Earth, even small interventions can have enormous consequences.
A well-meaning introduction of a species can disrupt an entire ecosystem. A new idea can change the trajectory of a culture.
The observers, if they exist, might know this too well. Their silence could be an act of protection.